the most about, what did you like the most? What did you like seeing that were there? Oh, Cliff Burton's. Okay. I don't know Cliff Burton, so um, what does I'm not I like music, but I don't pay attention to who does what. Sorry. Hey Gavin, good to see you. Oh, okay. Gosh. All right. So his guitar. Some of those guitars can be really expensive for sure. They are. I always wanted to play the guitar, but my fingers, I couldn't get over the feeling in my fingers for those things. So that was the problem for me. My fingers always hurt. So yeah, I know you're supposed to, I just couldn't. I mean, they get calloused over time. So yeah, but I just had trouble with that. So oh, you actually do you play, Chloe? Oh, okay, cool. Oh, nice, nice. That's and those are metal strings. Those are the ones that bothered me the most. The acoustic guitar and the strings that were, you know, out of nylon didn't bother me as much. Well, good to see you all here, Bradley and DeAndre, Gab. So we're going to have a drawing here, but we want to do some um, forced review. Okay, so what's going on this week, right, is that we have a post test. Um, so this is a, let's do, wait a minute, let's go here. Play. Okay, so we have a test over weeks 5, 6, and 7. All right, so all the forces. So I want to go over some of the vocabulary. We have a post test and vocabulary this week as well. So let's get started with looking at some of the forces that we have talked about in the past few weeks. We remember the four fundamental forces: strong force, weak force, gravitational, electrostatic, or electromagnetic. We had that. So we're going to talk about those. Those will be some of your vocabulary words. Thanks, Chloe. Thanks for getting in there, guys. If you guys can get in there, it really helps me. Hey, Dalton, good to see you. Grace, good morning. Journey, good morning. Cassidy, good morning. Ken, and Kylie, Madeline, and I've already said hello to Rachel and Chloe. So if you guys can get in there, I appreciate you guys. We have a science drawing for a free assignment for week 8. So we'll do this shortly after that. So we got 6 people here. Good morning, Stephen. All right. So gravity is due to, so remember, gravity is the pull on any objects with mass. Remember that? So even I have gravity, and this, because I have more mass than this computer, the computer is attracted to me. But they're, because we don't weigh as much as a planet, we don't have as much mass as a planet, we don't have a lot of gravity. We're not pulling on a lot of things. So, but there is a negligible amount. Hey, Gabby, good to see you. So who else do we have in here? Gavin and DeAndre. Remember, it's the force. Every object that has mass has force. The pull between any object with mass. So just me and my computer have a pull. There we go. Okay, so leaderboard, everybody's doing great. All right, so when an atom undergoes radioactive decay, the energy released is due to, remember, that's the weak nuclear force, right? The weak nuclear force where neutrons, when the neutrons and protons are not equal, then we get some problems with radioactivity. So the neutron turns to a proton, and then this changing of the element gets to a more stable form. So, oh, we got somebody else, Rachel, Dalton, Gavin. Thanks, guys, for getting there. So remember, this is the weak force. The weak force. All right, good job, guys. Just have 9 questions, just kind of as a review. I appreciate you guys participating in this. So, full question in here, blank is the force that binds protons together in the nucleus of an atom. Remember, that is your strong nuclear force, right? Remember, protons are positively charged and they repel each other. And in order for them to stay in the nucleus, they have to have something holding them together. And this is called the strong force, because without that, they would just be flying away. Without that, they would just be flying away, right? Hi, Kylie. Remember, that is the strong force here. The strong nuclear force is one of the 4 fundamental forces. We have gravitational, electromagnetic, strong, and weak. And again, I understand that. Oh, there we go. We got everybody. All right. All right. So here we go. And we got Bryce in here. Good to see you, Bryce. So, what is it called when something is pushed or pulled? Remember, that is a force. Anytime we have a force, pushing or pulling, we cause an acceleration. Force is a pushing or pulling that causes an acceleration. Still waiting on Gavin. There we go. A couple more questions with 5 out of 9. So, about 4 more. All right, just kind of trying to practice, practice, practice brings everything back to us. What direction does friction to applied force in an object? Remember, friction is always opposing the direction. It's opposite to the direction of the applied force. Remember, applied force is a touching force. I'm pushing something like a refrigerator. Gravity, not sorry, friction is going to slow it down, which is great, because if I want to push on without force of friction, if I pushed on it, it would continue at a constant speed and it would run into something. So remember, that's always the opposite to the direction of the applied force. So opposite, in the opposite direction of the applied force. Friction always that. You push on something, it pushes back on you, and friction is what keeps us moving. All right, let's go to the next one here. Number 7. So how does mass of an object affect its motion? So using Newton's second law, the greater the mass, the greater the effect of the force will have. Okay, so moving a boulder, it takes more force than moving a pebble, right? So it makes more sense that the more massive it is, the harder it is going to be to affect its motion, the greater the effect, right? Just waiting for John. Thanks, John, for getting in there. And we got Maddie. Thanks, Maddie, for getting in there. All right, question number 7. All right. Contact force is an object that's physically touching, right? Makes sense. Like contact paper is actually sticking on something. So contact forces are actually, you have to touch them in order. So applied forces, frictional forces are touching, right? Normal forces are touching. Um, and but gravity doesn't. It does. It affects us even without touching. All right. And I think we're on 2 more questions. All right. So gravitational force is a non-contact force, right? Because it's a field force. You can actually feel it between the Earth and the moon. There's a gravitational force there, even though they are not touching. Thank goodness they're not touching. Can you imagine what would happen if they did touch and all the problems we would have in that? The end of the world as we know it. All right. What is Newton's law of universal gravitation? All right. It's the object that has mass has gravity. And all objects with mass have gravity. Right? Because we do know that gravity pulls, but objects with mass have gravity. And that's how the Earth was formed, because clumps of rock with mass and gravity started clumping together, right? Just started clumping together here. All right. So let us end here, see what happens. We got, who's the winner? All right, Rachel third, Chloe second, DeAndre first. Good job, guys. So let me do this. Okay, where are we? Okay. So I want to thank all the people that in week 2, or I should say our 10 o'clock class, here are the people that did the assignments week 7, assignment 1 on time. Okay. And they also, because it was an unlimited assignment, they also got 15 points for it. So they did it until they got them all done and got 15 out of 15. There were more people that did do the assignment, but then they got 10 out of 15. So I'm not including them because they could still work on it some more. These people have gotten this done. So let me give a free assignment away to somebody here that did. These are all the people. Elizabeth, okay. And I don't think she's here, but I'm going to email her because she doesn't often show up, but she continues to do her work. And I'm going to, okay, I'm going to send her a link, or give her a email. All right. So again, like I said, I really do appreciate you guys getting in here and doing the assignments on time, keeping your grade up. Let's take a quick look at week 8. All right. So week 8 is all about forces. So here is framing the learning. What is a force? The 10 different types of forces, fundamental forces, Newton's first and second and third laws, gravity calculations. So most of your grade is going to be on vocabulary. A few of them are going to be some calculations, right? We do have lots of videos you can go over. You can also go over the conference videos. If you're looking for the vocabulary, make sure that you go to week 5, 6, and 7 and look in the notes there and start writing your vocabulary down. If you haven't, put them into note cards, put them into flashcards, have them with you in your notebook. You can submit that as offline tracker. Now today what we're going to be doing, we're going to talk a little bit about terminal velocity. Okay, and I've got some questions for you. So let's take a look at this video here. And I have to set it up so you can hear it. So I did not set it up when I did that. Let's do this again. Put the link to the video volume. I will move my camera, turn my camera off so you guys can see better. All right, so this is a short video on terminal velocity. There is an exit quiz on this as well in the form of the video and questions, 5 questions. You guys can hear that okay? Can can't you?
When an object or person falls from a great height, they are pulled towards the surface of the
Thanks,
Earth by the
Chloe.
force of gravity. As the
Anybody
object or person
being a
falls, they
skydiver?
accelerate, meaning they move faster and faster towards the ground. However, the air resistance or drag force pushes against them, slowing them down. At some point, the drag force becomes equal to the force of gravity, and the object or person stops accelerating. This is called terminal velocity, which
All right.
can be different for different objects depending on their shape, size, and mass.
All right, so terminal velocity is what we're talking about today. So let's do some questions here. All right, so there's like one question on the test on terminal velocity, but it's a really interesting subject here. So let me do this. Okay, so let's take a look at the poll here. What force pulls objects to the people toward the surface of the earth when they fall from a great height? Is it magnetism, air resistance, friction, or gravity? Let me thank you guys. Thanks, Rachel, Kendrick, Grace, Chloe, Bryce, Madison, Bradley. How about you, Stephen, Renaya, Madeline? Guys, get in there. Kylie, Cassidy, Journey, Jasmine. We got 7 out of 19. Thanks, guys. And again, like I said, it's your job to do the polls. It helps me become a better teacher to let me know who knows what, and to go over it with people. It's part of the data that we have here. Okay, so we got 9 out of 19, almost half of the class, 9 out of 19, and we're doing pretty good there. You guys, for some reason, I had 11 out of 22 in my last hour, which was unusual. Usually it's like crickets there. So 9 out of 19. So how about you, Cassidy, Madison, Rihanna, Stephen, Gavin, Gabby? Can you guys get in there and put a vote in? What is this? I got 10. Thanks so much. Who did I get? I got another. Stephen. Thanks, Stephen. Come on, guys. Don't be the ghosts that you are. All right. Be participating. It helps me more than you know. All right, so I got 10 out of 19, a little bit more than half. And the answer here for this one is D, right? Gravity. Gravity pulls you down. Now, see the drag here, right? Gravity's pulling us down. Drag, a lot of times we've been calling that the normal force, but remember the normal force is when you are standing on something, right? The force of gravity is pulling us down. The normal force is pushing us up. But in this particular case, drag makes a difference here. How about this question here? Let's see if we can get the same 10 or 11 people. What happens as the object falls due to gravity? Now, again, because of air, right? We do slow down, but before we hit the air, what happens? We go faster and faster and faster. And what is that called? What is it going faster and faster and faster? Yeah, thanks, Bryce. Thanks, DeAndre, Grace, Kendrick. You guys got it. Come on, guys. Come on, Kylie, Madeline, Cassidy, Jasmine, Gavin. Come on, let's do this. Come on, get in there. Got 7 out of 19. Come on, Bradley. Don't be a wallflower. Come on, Blake. So 10 out of 19. All right, so I've got most of you guys in there. Thanks so much. And it accelerates. You guys are exactly right. It accelerates, but then it stops accelerating. Why is that? What is it that they talked about that's dragging us back, making us slow down to 190 miles an hour? Now, 190 miles an hour is still going to kill you if you hit with full force. I had a friend, I should say an acquaintance, that was a teacher that liked to skydive, and his parachute didn't open, and he was able to steer himself so that he could find something softer to fall on, and that was a lot of hay in a farmer's field or near his house. So but he did break a lot of bones, but he did live. All right, so when the air resistance equals the force of gravity, right? You guys are right. Air resistance equals the force of gravity. That causes the drag. All right. All right, so let's take a look at the last part of this video. It's kind of, they do some animation in here. Let's take a look.
Terminal velocity for a human falling through the air is around 120 miles per hour, or about 193 kilometers per hour, which is far too fast
I thought
to
it said
safely reach the
190.
ground.
120.
This is where a parachute comes in. A parachute increases air resistance due to its shape and size, creating a larger surface area for the air to push against. This slows down the person or object's descent, allowing them to land safely on the ground. Okay, let's go through it one more time. When a skydiver leaps from a plane, they initially accelerate due to the force of gravity. As they fall, air resistance gradually increases until it balances with the force of gravity, and the skydiver reaches terminal velocity.
Arrows there.
At this point, the skydiver deploys their parachute, which increases air resistance and slows their descent.
All right, it didn't let you guys see them landing there, but take a look at this one here. What is the term used to describe the point where drag, the force, equals the force of gravity? Is it equilibrium point, terminal velocity, free fall, or acceleration? All right, thanks, Grace. Thanks, Bryce, Kendrick, Madison, Rachel. All right, so it says right there at the top, terminal velocity. All right, so terminal is usually means the end of life maybe, but terminal is the end. So that's the 120 miles an hour that we get to get there. 120 miles an hour is without the parachute. And again, if you've ever seen in action movies, you can see where people speed up by making their body shape as small as possible, making them into a ball, and then they can go fast or they can slow down by spreading their arms out, right? Thanks, guys. So terminal velocity is what we're looking for here, right? So terminal velocity is what we got. And there's a short video on this, on terminal velocity, and for your exit quiz. All right, and if you look at this assignment here, this is a skydiving assignment that is an online where you can actually take something and drop it. You have to kind of go up to the height here. Okay, so let's see if I can get this to redo this. Okay, so we drop something and notice it gets accelerating faster and faster and faster here until you get 20 newtons of air drag and 20 newtons of weight. Constant velocity, it's still going 10 meters per second, right? Same thing if I drop a gold bar, it starts to accelerate to 200 newtons. And then when it gets to 200 newtons, then the drag gives us terminal velocity here. And so notice that the arrow doesn't continue going faster and faster. You can attach some some parachutes to these. Okay, so height and fall makes a difference as far as how fast you go. So if you have a longer fall, you can make it happen. All right. Faster. Okay, so terminal velocity, just in review, the force due to drag, air resistance is air friction, is that its maximum and balances the fall of an object. So it becomes a balanced force. Balanced force, remember, shows could be at rest or constant velocity, and that's what terminal velocity is. It's not going any faster, no longer accelerating. So if we look at a graph of velocity versus time, right? So between A and B, a skydiver falls, the increases until we get some drag. Okay, so here between A and B, we have we show that is increasing acceleration, straight line, constant acceleration in the downward position. Um, Acceleration starts to decrease, so that's why we have this curve. And then constant velocity is this terminal velocity. So a flat line here means it's going to be staying at a constant speed. Okay, in the case of free fall, you can so depending on the size of the object, so forth. So all right, so type. So let's see if we can do this one together. So let's look at the acceleration. We're kind of reviewing acceleration. Remember, the acceleration is the slope of velocity. Okay, so we have velocity final minus velocity initial divided by the change in time. Okay, so in this particular case, velocity final is 4.5 meters per second, right? And minus the starting velocity, which is 0. So it's 4.5 divided by the time is going to be 4.5 meters per second squared. So if you can put that in there, 4.5 meters per second squared, that's the shift key, and number 6 will give you the up arrow. Thanks, Kylie. So again, we found the slope, which is the rise over the run. So it's 4.5. We got that from looking at the chart, 4.5. And 0 was my initial one, 0, right? So we got 4.5 divided by 1, which gave us 4.5 meters per second squared. I know it's hard for you guys to write on those kinds of things or type, but remember it's shift 6 for that up arrow. 3 people, thank you guys. Right, so what's the acceleration here between between acceleration from 0.1 second to 2 seconds? Okay. Oh, I did this again. So we're going to do, we're going to do this one between 1 second to 5 seconds. Okay, 1 to 5. Okay, so this is going to be, so our initial velocity is going to be 4.5. So that's our where we were, 4.5. And our final velocity again is right here, 8. All right, so it's going to be final velocity of 8. If you guys can get the answer before me, that's great. 8 minus 4.5. So we're slowing down. And we're going to take between 1 second and 5 seconds. So 5 minus 1. So this is going to be 3.5 divided by 4. What do you get? 3.5 divided by 4, and that's going to be in meters per second squared. 3.5 divided by 4. Need my calculator there. 1 point something, right? All right, let's calculator out. Calculator, where are you, my calculator friend? Here we go. So 3.5 divided by 4 seconds gives us, nobody's got, oh, right. So 3.5 divided by 4. Nope, it's not 5. Okay, 3.5 divided by 4. Anybody got it? 3.5 divided by 4 seconds gives us the meters per second squared. Well, thanks for participating, Stephen. I got a lot of people are scrambling to get their phones out, turn them on, and see how they do on those. There we go. Thanks, Kylie. So 8.75 meters per second squared. Okay. So last question, what is the terminal velocity? Remember, the terminal velocity is the object where, remember, this is the flat part here. So what answer is the flat part, the terminal velocity here, right? Remember, we just come over, find this number here. And remember, it's going to be in meters per second because it's not speeding up. Its acceleration is stopped. It's a flat part. Thanks, Madison. Yep, you got your answer there. So that is the terminal velocity there, 8 meters per second, right? So we're losing lots of people toward the end here. All right, 8 meters per second. All right, so what you have today, ladies and gentlemen, all right, you have, go over here. Okay, so we have in our module, we have an exit quiz, right? So module 8 has an exit quiz that's open today and through tomorrow. So week 8, why all these are open. Exit quiz 311, exit quiz on terminal velocity. If you'll notice, there is the video, so refresh your memory, and 5 questions. Okay, these are bonus points for you guys. If you have any questions for me, I'll open up the big blue button for you and you can pop over and see what your grade is. Remember, you've got a lot of things to do. I didn't have that many people do this assignment. Week 7, assignment 1 and 2 are both short, only 10 questions between both of them. They were due on Friday, so get those done today. Today, W7 quiz is due. So if you've gotten those done, remember, week 8 is mostly, the assignments are mostly vocabulary. So go look through your vocabulary and get those vocabulary assignments done. Week 8, assignment 1. All right, I'm going to stop right there, ladies and gentlemen.